Welcome everyone and welcome to our sessions on artificial intelligence. So in the previous sessions, we did a lot about the logistic regression problem and how to solve a logistic regression problem. That is nothing but using your data set and classifying your data into different classes. So what are the classes that we classified earlier? So we did a project on that is a simple project on our diabetes data set. So we classified the person as whether the person is diabetic or non-diabetic. So that was the project that we did earlier. But right now we'll focus on the real life data sets. What is actually happening in the real life data set and how real life data sets are actually being used in the problems of machine learning. There are a lot of steps and a lot of things that are involved while dealing with real life data sets. So today we'll be doing a logistic regression problem. That is nothing but we'll be using logistic regression for our classification. So that is the algorithm, logistic regression algorithm for classification. But the data set that we'll be dealing is quite a different data set, because the problem is there are some data sets which are not directly available and which you can't directly apply to a machine learning algorithm. You need to do some data cleaning. So what is data cleaning and why do you need to do this data cleaning is very important to understand. So data cleaning is nothing but whenever you have lots of data available with you, there are some missing data in the middle. Suppose you are given a contact form and you are asked to give out all your contact details, but there is a column called as landline number. So if you don't have a landline number, you will leave that as a blank one. So then you come to your data set and see that the landline numbers are blank for like a lot of cases. So that is nothing but your missing data. So there are a lot of examples where some data is not applicable to some people, so they leave the data blank. Whenever you're trying to do a machine learning implementation, whenever you load the data set, if any of the middle row is blank, obviously you can't run the program because it will give you an error stating that this data is blank. So what we can do is either we can remove the blank values, but removing the blank values, what is it doing? It is reducing your data set. So as I told you, whenever you reduce the data set for training, the accuracy gets decreased and the optimum results which you are looking for will not be available. So very important to not reduce your data set and do some data cleaning in such a way that majority of your data set is also saved, and in the same way you are able to get your optimum results. So what we'll do is we'll see that our real life implementation data set where a lot of complexities is being involved. It is not a straightforward way that we do the logistic regression just by applying our logistic regression function and getting the results. Here some amount of data cleaning needs to be done. So we'll see which is the data set and we'll try to understand how this data set is quite complex and how to come to the conclusion in these kinds of data sets. So the data set that we'll be using is called as Titanic data set. So you can come to Kaggle and look for your Titanic data set. So what is this Titanic data set? So one thing about the Titanic data set is nothing but on April 15th, 1912, you already know the Titanic made her maiden voyage. That is nothing but it started its first voyage, but due to the iceberg incident, so the Titanic crashed and it sunk. So that is the problem. So what we are trying to do here is we will try to take in the data. So this data set was created by some data analytics teams in famous universities like Harvard and Massachusetts. So they have created this data set. So what is this data set entirely telling us is pretty simple. So in this data set, what we do is we have a CSV file. So in this CSV file, we have a column called as passenger ID. So what is this passenger ID is telling you is, it is telling us what is the number given to the passenger, survived, P class, name, sex, age, SIB, SP, parch, ticket, fare. So a lot of things are there here. So what I have done is I've created a documentation for all this. I'll just share it with you and I'll discuss with you also what all these columns mean. So we'll just move on to the data set and we'll understand what is this data set basically. So as we can see here, so there are the variables and there are the definitions and there are the keys here. So so the major important thing that we need to understand here is from this data set, we have the passenger ID. So what is this passenger ID? It is nothing but our IDs is nothing but random numbers that are given to the data set. So we have random numbers or it is like a series of numbers that are given to the data set. That is what is your passenger ID. So totally how many passengers we have? 891 passengers data we are having in this data set. Okay, that is fine. So this is one part that is having all the passenger IDs. So passenger ID is telling me that it is nothing but a random counting number which is counting all the number of passengers. Okay, done. So I have this passenger ID column, so that is my first column. Then I have a column called as survived. So what is this survived is similar to your diabetes data that you have. Survive is nothing but whether the person survived at the last. So whether the person survived in the Titanic sinking, whether the person did not survive, that is what it is telling. So 1 is indicating the person has survived, 0 is indicating the person didn't survive. So this is the important case that you need to understand. So 1 is telling you yes, the person survived, 0 is telling you no, the person didn't survive. So this is what is your survived column telling you. Survival is whether the person survived after the Titanic ship sunk in the ocean. So this is one column there. So then we have something called as passenger class. So what does this passenger class actually tell you is passenger class in the sense, so how you have your economy as well as your business class in your flights. So the same thing is happening even in the ship. So even Titanic had a passenger class which was telling which was your, that is nothing but passenger class. So which is your class, whether it belongs to first class, second class or third class. So depending on the class, so they have assigned the passenger class to each and every passenger. So this is there in the passenger class. Okay. So after passenger class, it is basically telling you the name of the particular person. So what was the name of that person who was traveling in the ship? So that was there. Sometimes there were many people or they had their first names and second names. All those things are mentioned here. Okay. So this is the name of the person, whether that person survived or not. Then you have the sex, whether the person was a male or a female. So this also was done. So this data is also available. So then you have an age. So which age was the person been there? So what was the age of the person who aborted the ship? So this is there. So then you have something called as SIBSP. So what is this SIBSP? Is nothing but SIBSP is telling us siblings or spouses aboard the Titanic. So if I was there, so whether if I had my siblings, so if I had my brother or sister there, so if my brother is there, so then it would tell me the number of siblings that I had on board. So siblings or spouses. So this SIBSP is telling whether I had a sibling or a spouse so involved in there. So that is also there. So then you have something called as parch. So what is parch? Whether I had my parents or children on this particular trip. So whether I had my parents or my children on this particular trip aboard. So that is telling us these two concepts. So SIBSP is telling me the basic thing, that is, yes, we move on to the explanation of the data set. That is, we completed the data set explanation, that is until SIBSP, which is telling you the number of siblings that were actually there on board the Titanic. Coming to the next part, that is nothing but our parch. So what is the parch telling you is, okay, parch is telling you about the number of parents or children aboard the Titanic. So majorly what happens is whenever the parents are accompanying, so it is nothing but how many parents or children that are accompanying a particular nothing but a traveler. So this is very important because it is linking up all the details. So then we have our ticket number, which is telling you what was the actual ticket number that was issued. Fare is nothing but the price. So price is telling you how many dollars which were charged for a particular person. So this may vary according to the class, that is nothing but passenger class here. So 1, 2 and 3, and also depending upon the place where the particular person is not has departed or aboarded the ship. So this is a major thing. So then we have something called as embark. So what is embark? Embark is nothing but the place where the person climbed up the ship. So basically it is nothing but the place at which the person climbed up the ship. So here is how we actually make up the story on this entire data set. So first thing is nothing but how many people survived. So that is very important. So this is nothing but a data analytics part. So we can analyze that how many people survived by counting the number of zeros and ones. So then passenger class, we can try to see which passenger class person survived what incident. So if he was in a first class or second class or third class, because people of greater, classes are nothing but a greater luxury were given more chances to get out of the ship using rescue boats. So then name, we will remove this. See, one basic thing you need to understand while dealing with all the important data sets is which data you should consider, which data you should not consider. Here the main thing that we are dealing here is nothing but trying to understand which of the data set or which part of the data set is very important for us. So the part of the data set that is very important for us is nothing but the data that is survived data, then the passenger class, that is also making sense. But name is not making any sense because it doesn't depend on the name. So whether you survived or not on a Titanic ship doesn't depend on your name. So that is also important. So then we have sex, whether male or female. Yes, this is also very important to understand because female and children were given more preferences on boarding the rescue boats. You already would have heard the story about the Titanic where there were rescue boats. So those rescue boats were able to just push the people. That is nothing but females and children were given more preference. Age is also very important. Elderly people and children as well as women were given more preference. So that is how the Titanic people of lesser age had little chances of survival because people who were older were given more preferences. SIB, SP is nothing but number of siblings that were on board. That will tell you about how actually your data that is nothing but how your data is actually helping you out to understand all the important parts. So what is that? How many siblings were there? This is basically for family tracking. So then you have park or nothing but how many parents or children were there along with you. So parents, PAR, parents, CH is nothing but children. How many parents or children accompanied you? So this is also telling you chances of survival. Again, ticket number. So ticket number doesn't mean anything. So we will remove the ticket number or we will not use it in our whole prediction part. And we have fare. So fare also will not be using. Cabin. So here cabin also we won't be using here. So and embarked, yes, we will be using embarked because this is telling you where the person actually aboarded the ship. So this is the entire thing that we will be doing about our data set. So what we will do is using all this data, we will try to analyze something or we will try to apply our logistic regression. But one important thing you need to understand here is most of the columns have empty data. So this, if you consider the case of cabin, so you can see the cabin here. So almost 90% of your data is empty in this cabin. So very important to understand that it is not like the other data sets where you had your data filled all the time, but in this particular kind of data set, the data is not at all filled. So we have a lot of gaps and spaces in this data set. So this you need to analyze here and try to act carefully. So this is not like a generic data set where all the data is filled, but we have some gaps that we will analyze how to fill the gaps or how to actually make sense of this entire data set. So two things are there here. One is nothing but data sets are empty and some of the data sets are irrelevant for our prediction. So what are the data sets which are irrelevant? Cabin number, fare, ticket number as well as the name. So these columns we will be removing and we will actually use the rest of the columns to predict what. So the prediction is nothing but the label is survived. So you need to either predict 0 or 1, whether the person actually survived during the Titanic ship accident or whether the person didn't survive. So this is the thing that you need to analyze as well as predict at the end. So since this is a classification problem, we will be predicting whether the person survived or not at the end. So this data set we will be using. But here is a simple trick to understand. So we will not be working in a regular way, just applying our logistic regression. So we have other parts also left in this particular example. So what is the other part is data cleaning. So data acquisition as well as data filling. I will be telling you what is that actually, but we'll try to open our data set and analyze our data set first. Coming to our programming part, it is pretty simple. So we'll just start with importing the libraries. So the libraries that we'll import are pretty simple. So import pandas as PD. You already know what is PD. That is nothing but alias names given to your pandas library. You know why you need pandas, because you need to open the CSV files and start using it. So that is why you need pandas. Then we will try to import NumPy. So why NumPy? To store your large data, it is very important to store it in the form of NumPy. That is nothing but a number library in case of your Python that helps you storing large number of data. But nowhere you will be using NumPy directly, because when you import your data sets from your CSV files, all the data will be stored in the form of NumPy arrays. So NumPy array is nothing but a large array where you can store a lot of numbers. So that is NumPy as NP. So then what we'll do is for graphical representation, so we will import our matplotlib. In matplotlib, we have pyplots. So matplotlib.pyplot as plt. So this is what we'll be doing. So then what we'll do is another graph. So how we did our confusion matrix using Seaborn. Seaborn is also another graphical library that we'll be using. So import Seaborn as SNS. So this is the thing. So import Seaborn as SNS. So four things. One is pandas, NumPy, matplotlib and Seaborn. And later we will take in the other library that is nothing but our scikit-learn. So these 4 libraries that we'll be importing. So you know why we are using these shortcut names, because they're alias names. You can use them anywhere, so that they'll help you in nothing but not writing the larger names. Just by writing the smaller names, you can entirely code whatever libraries you want. So you don't need to type in your large names while coding. So it is just a shortcut or alias names that we'll be using. So the next part is we'll be storing some data. So what is the data? It is nothing but we'll read the CSV. So pd.read_CSV. Okay, pd.read_CSV. So the data set, I have got it stored as train.csv. So you can see here. So in the logistic, I have this train.csv. So this train.csv has all my data. So what I will do is I will use this train.csv. Since it is in the same folder, I need not mention the whole path. Else you need to mention the whole path. So that is how it works. So then what you need to do next is pretty simple. So to check whether your data has appeared or not, so we'll just print out data. We'll see what is the data that we are having. So we are just checking out in the print statement. We are seeing what is the result. So we are waiting for Python to execute. So as you can see here, we can see all the data. That is nothing but different columns of data we are seeing with all these examples. But one problem we have is nothing but in our cabin. So you can see cabin. So there is some value called as NaN. So NaN is nothing but empty. So instead of empty, it shows as NaN. So NaN is equivalent to empty. So there are a lot of data which is empty in this particular cabin. So others we are not able to see with the help of this, but all the data has been arrived. So we have successfully done this point of getting our data. But one more thing what we can do is we can draw a heat map to see which is the empty portion, which column has most number of empty slots and which column doesn't have empty slots. So this is what we'll do. We'll see which column has empty slots. So what is empty slots? It is nothing but how many data is empty in which column. So with the help of just the CSV file or a data set, it is difficult to analyze. So with the help of a graph, it will be much easier for us to analyze. So what we'll do is we'll just draw a heat map. So you have already learned what a heat map is. So heat map will tell you the values. So whether the values of what concentration the value is present. If the data is there from above 100 or 200, the concentration of color changes. So if the data is below some particular value, the concentration of color, again a light color will be chosen for lesser data values, a darker color will be chosen for greater data values. So this is how heat map is being represented. So what is heat map? It is nothing but a graphical representation of the values or variables. So if you have more values or if you are dealing with numbers, so more the numbers, greater the color concentration or darker the color. So if you have lesser numbers, the concentration of the color or the color will be much lighter. So that is how you need to understand heat map. So it is nothing but a graph that is available in your Seaborn package. So what we'll do is we'll take in data, but what we are willing to see now is data which is empty. So what is empty? It is nothing but we need to see the data where it is null or empty. So there is a function called isNull. So what that function does is isNull function. So it will just show us what is the empty portion. So what is this empty portion there, or what is the empty data that is there in our data set. So what we are plotting is we are plotting the entire data.isNull. So whichever data is empty, we'll be able to see. So that is what we are plotting. So heat map is telling you if values are greater or more concentration of values are there, it will give you a darker value. If values are lighter, it will give you a lighter value. So that is how lighter colored value you will get it. So this is how we are doing. So if you want to show the heat map, it is plot.show. So if I try to run this code, what would I get now? Yes, so this is the example that you need to understand. So what we are trying to do now is we've just drawn a heat map. So heat map is telling you what is the value that we are having. So is null function, what it is doing is it is searching for your empty part. So if you are searching for empty, so it is telling you that in most of the data that we have, cabin has the most number of empty spaces. So this white or this yellow colored portion is indicating that these are the empty spaces or these are the empty data. But this is indicating that, okay, so in which columns we have empty data? So passenger ID is completely filled, survived is completely filled. So then we have passenger class that is completely filled, name is also filled. Okay, so then we have sex also filled and all the other data we have filled. But we have the major flaw that is nothing but our cabin. So here in our cabin we have major flaw. That is nothing but we have all the empty spots or empty data here. So what can we do here is pretty simple. We can either ignore this cabin because this cabin number doesn't tell you anything about the survival rate. So this we can ignore. But still we have lot of data which is empty in the age column. So this is a problem because we consider age as one of the important factors for deciding whether the person has survived the accident or not. That is or nothing but survived the Titanic sinking or accident. So what we need to do is we can't neglect this, but we can neglect this cabin. Embark, yes, there are few gaps in embark that we can fill, so that is not a problem. So there are two methods of removal. So what we can do is whichever column is empty, so we can remove this entire column. So that is one method. So whichever row in a particular column is empty, you can remove that particular row itself. So that is also possible. But the problem is if I remove the ages row, so then all the data will become empty. So if I want to remove all this data, then I will be left with only a small part of data set. This is also very important to understand. You can't just remove the rows stating that any of the particular column in that row is empty. You can't remove it because age has the majority of our column. So the age data in our majority of our rows is empty. So you can't remove everything. So you will be left with only 20 or 30 data. So age is empty in most of our data set, but we need to do something in our age to fill it up. So this is very important to understand. But cabin we can ignore that because cabin we are not considering at all. Ticket, fare and cabin as well as the name we are not considering. So you can remove this. But embarked also we need to do something to fill up these values. And again age we need to fill up. We can't remove the column. So if we remove the entire row, what will happen is the entire data set will get reduced. So now we have around, for example, we have around 700 data. So if we start removing the columns which are empty, we'll be left with only 100 to 50 data. What we are doing is we are reducing the data set, hence we are reducing the amount of data that is available. So that is very bad and we shouldn't do this. So we need to think of an alternative what we can do. So what we'll do now is pretty simple. After doing this, what we'll be doing next is pretty simple. So we just want to remove some of the empty spaces. So as I already told you that, so as I have already seen what has happened, that is nothing but we had our data. So when we had our data, so we need to remove certain columns. So the first column, that is what we'll be doing is we'll be adding some dummy data here. So which is the dummy data we'll be adding is pretty simple. As you can look into the heat map. So in the heat map, you can clearly see that I told you cabin is nothing but the cabin number. So we don't need the cabin number. We will remove this entire column. So we will not be using this column at all. But what we will not try to do is whenever we have empty data in this age, so if we remove this entire row, what happens is we are losing out on lot of data. So what we'll do is we'll add some dummy values and try to fill up this age. So how to add dummy values is nothing but we'll create a function. So what is the function that we'll be creating is pretty simple. So we will create a function called as define impute age. So impute underscore age is the function. So what is a function? Basically, function is nothing but a set of code or nothing but a group of codes which will perform a task when it is called upon. So what we are trying to do here is, in the age column where we have some data, we are trying to add some dummy age column. So what we'll try to do is, we'll take in the parameter that is nothing but the column. Okay, so what we'll do is, we'll assign a value called as age is equal to column of zeros. So what we are trying to do is, we are taking in age, which is nothing but our columns of 0. What is columns of 0 is nothing but we are considering the columns of 0, that is our data. So what we are trying to do is, we will take two columns here. So first column is our age column, second column is our passenger class column. So we'll just see. So as you can see here, we'll take in two columns, which is our two columns, passenger class we'll take and age also we'll take. But what we'll try to do is, using this passenger class. So passenger class is completely filled. We don't have any empty data inside passenger class. So we'll use this passenger class to fill in the age column which is empty here. So what are we doing here? We are taking in a numpy array, that is nothing but our data frame, pandas data frame we are taking inside this. This is columns. So the first column is nothing but age. So we'll be inputting only the age as the first column. So then what we'll be doing is, we'll call another variable called as passenger class, that will be in columns of 1. So this column will contain two parts, that is nothing but columns will have two parts. So I will just write it in comment. Column 1 will have age, column 2 will have nothing but our passenger class value. Why we need this? Because we are using the passenger class which is completely full to fill up for the age. So age is empty in lot of the places. So we will use this passenger class to fill up the ages. So that is what we will be doing right now. So this is an intelligent technique. So you don't need to actually remove the rows or column if it is empty. We can put some dummy values so that it can also be done. So what we'll do is, if pd dot is null. So what is this is null function telling us? Whether a particular row in a column is null. So if it is null, so what you should do is, this is telling you that if the age column. So what is age column? The column of 0. So this is the input that we will be giving, since this is a function. So we are here, it is not just nothing but a dummy variable that we are using, but actually we'll give an input of nothing but age and passenger class. So that will have age will store the first column, that is nothing but age column. So passenger class will be stored in the second column. So we'll use this. So what we are trying to do is, if the age column is empty, so if there is any age column empty in any particular row of that particular column, so what we'll try to do is, we'll try to append some values. So we'll add some dummy values. So how to add dummy values? Using passenger class. So if passenger class is double equal to 1. So if that particular passenger class is 1, so what we'll try to do is, we will try to return nothing but 37. So it is just telling you that people of higher age will obviously have a lot of money and they will go for higher passenger classes. So people who have lesser money will not have, lesser age will not have so much money. So they'll go for lower classes. So this is what we are telling. So this is just an assumption, because we don't want to leave out that column and we don't want to delete that column. That is why we are trying to add some dummy values. So similarly, what we are trying to do is, we are trying to add in dummy values. So here we added a lot of dummy values. What dummy values we added is, we will consider two parts. So first we'll consider the age. So if there is any null data, if any cell or if any column or if any row or pointer is null here, so what we will do is, we will consider this null and we will see the passenger class here. So if the passenger class is 3, so we will append the age of nothing but what? 24. So if the passenger class is 1 here, so we will append the age of 37. So if the passenger class is 2, we will append the age of nothing but 29. Just we are trying to add some dummy values here. So that is what we are trying to do here. So very simple to understand. Since we need not leave out all the values, we are trying to add some dummy values here. So that is what we are doing. So after doing this, what we'll try to do is pretty simple. So we told that we are trying to add this part. So if it is null, so it should return all these ages, but we need still more things here. So what we'll try to do is, if the age is not null, so what we should return, we should just return the age itself. So if the age is already available, that is nothing but if the age is not null, what you need to do is you need to return the age itself. So return age. So this is done now. So what we did right now is we created a function called as impute age. So this impute age takes in a data frame, pandas data frame. So pandas data frame needs to have two columns. So which is the two columns it needs to have? One is age and the other one is passenger class. So after using the age and passenger class, it will check whether the age is empty. So if age is empty, it will see the passenger class. So if passenger class is 1, it will return age as 37. If passenger class is 2, it will return 29. Else it will return 24. This is just a simple assumption that I am doing for not leaving my columns empty. So this is the thing that I will do for not leaving my columns empty, adding some dummy values. So you know, impute is nothing but when amputation is nothing but cutting something, imputation is nothing but adding something. So this is nothing but adding dummy values. Okay. So what we'll do is we will try to see, this is just a function, we have not applied it anywhere. We'll try to apply this function also. So we have data that is nothing but our whole CSV file. So data of age is nothing but the age column is equal to, so what it is returning my age. So age is nothing but the column. So data of age is equal to data of, so what should we give now? Two columns I need to give. What is the two columns? Age and passenger class. So I'll give age and passenger class. Okay, then what I need to do? I need to apply to the function. Apply impute underscore age. So this is how we are applying our whole data to the function. So what we are trying to do is, this is the impute age function where we are trying to append some dummy values to the ages. But very important thing what we need to understand is, this is just a function. We didn't apply it to our data. To apply it to our data, we have data of age, that is nothing but the column which has all the age. So this is getting initialized with data of age and passenger class. So this is the input. So what is the input? Columns. So here columns is nothing but data of our age and passenger class. As I already told you, your column should have two columns. That is nothing but age and passenger class. We are applying those two columns. Dot apply impute underscore age. So this is the function that we are applying. But one more thing we need to tell here is axis is equal to 1. So what is axis is equal to 1 telling you? This is telling you that the axis is 1 is indicating that it is a row wise operation or nothing but it is taking into consideration the column. So all the row wise operations are considering in the form of column. So column wise we are trying to append the data. So this is what we are trying. Axis is equal to 1 is nothing but we are applying the data in a column wise manner, which will each and every row will get executed. So the order is column wise, it is not row wise. So very important to understand. So after this, we will try to see whether what is the data, whether a data has vanished or not. So we will use this sns.heatmap to see data.isNull function. So this isNull function is telling you whether the data is empty or not. So this we will try to see whether our data is removed or not. That is nothing but our age value is filled up with this dummy values or not. So this is there. So we will try to see here in the graph. Okay, double equal to here. So we'll see both the cases. So we are displaying both of them. So which is one? This is the first one. So where we have some data in our age. So we'll remove this. That is nothing but we have plotted another one. So you can see here. So there is no empty space in age. So what we have done is we have appended all the dummy values to our age. So this is how I have done my data cleaning. So the major thing in machine learning or artificial intelligence is data collection and data cleaning. So if you don't clean your data, obviously it is very difficult to apply. So one more thing we need to do next. So since our age data is all clear, so we plotted our heat map to find out which is the null value. So we found out that age had null values. We removed it by imputing with nothing but random values of age that using passenger class. One more big task we have, that is nothing but cabin. So we need to remove this cabin column. I told you cabin number doesn't have anything to predict whether the person survived or not. That is why we'll remove this cabin column also. So how to remove this cabin column is pretty simple. So we have an option that is nothing but we have a command. What is the command that we'll be using is nothing but data.drop. Okay, so data.drop is the command. So which column I need to remove? The cabin column. So I will remove the cabin column, and axis 1 is telling that it needs to be done in the terms of column wise. So the operation is column wise. So you need to remove the cabin column, and it is a column wise operation. Axis is equal to 1. And the next thing is, after dropping it needs to be stored in the same data or not. This is very important. So very important is you need to use in place operation. So in place is equal to true. So what is in place is equal to true telling you is very important to understand. Please understand this, guys. So when you take in the data that is nothing but the whole CSV file. So when you remove this cabin, so after removing it, should it be stored in the same variable that is data or not? So if you use in place is equal to true, after removing this cabin, the removed data will be stored in this data only. So the removed columns other than cabin will be stored in this data only. You don't need to store it in any other column. So this is similar to the concept that data is equal to data.drop. So we are telling that it needs to store in data only. So this is what we are telling. But if you use in place is equal to true, it will use the same variable name to store the edited part also. What did we edit? We removed the cabin here. So again we'll see whether we got that is nothing but we removed the column or not. So how to check? Use this sns.heatmap to see whether our data is empty or not. So we'll just comment out the earlier ones because we don't want to load them. We'll just see whether our data is removed or not. So which data? That is nothing but our column data is removed or not. Which is the column we plan to remove? The column which we plan to remove is nothing but our cabin column. So we should check whether our cabin column is removed or not. Yes, so you can see here our cabin column is removed. Only one thing we have in difficulty, that is nothing but our embark column. So what is our embark column telling you is, it is telling you that only these two empty spaces are there. That is nothing but we have dummy values in this embark. 2 passengers have this embark dummy. So what you can do now is you can remove the entire row. So this is the operation you need to consider. Why didn't I remove the entire row earlier is because in age I had lot of values. So if I remove the rows, I would not have like many data at all. So this is why I didn't remove it. I added some dummy like values. Since in my predictions nowhere cabin number will be involved to predict whether the person survived in the like the Titanic accident or not. So that is why we removed that entire column. Here we need to understand, we need to remove this whole row because this row has some empty data. So we don't want to append this. We'll remove these 2 rows where we have some 2 empty data in the embarked column. So we'll remove that. How to remove it is pretty simple. So what we'll do is we have an option called as data.drop is the same. So we have something called as data.drop NA. So what is NA is nothing but remove the row, entire row where there is one data that is empty. So wherever there is empty data, in whichever row there is empty data, remove that entire row. That is what we are telling. So in this embark we have some empty spaces, this. So what we will do is if you use drop NA, if it finds any cell in a particular row as empty, it will remove that entire row. That is what we are doing. So drop NA is telling that remove all the rows where any cell is empty. If we use it earlier, we will use a lot of data. That is why we didn't use earlier. Now we have only 2 empty data in the embark. That is why we will remove those 2 rows. So we will use in place is equal to true. That is nothing but we are telling that after removing it, store it in the same variable name. That is nothing but our data. So what we'll do is we'll try to use this graph to see whether our embarked empty data is removed by removing the entire row. So we just see it in the form of a graph whether our data is removed or not. So now as you can see here, the data is entirely removed. So this is telling you that the data is entirely removed, so there is no empty data. So there is no empty data at all. Entire thing is completely filled. So this is telling you that the data is completely filled. You don't have any empty data. Now it is the time to use our logistic regression principle. Why? In earlier, see, very important to understand, our old data sets were just examples of direct data implementation. You didn't have a problem of data getting mixed up, data getting mixed up, or data which had empty columns or rows. So a lot of things were there. But this is a challenge where you can see that a lot of rows are empty. You can't delete the rows as well. So a lot of challenges we faced and we have come till here. So now is the time to implement our logistic regression. But to implement our logistic regression, we need to still understand our data first. So what is the data that we are trying to understand is pretty simple here. So we'll see here. So what is the data that we are trying to understand is nothing but we'll use all the data. Okay, we have removed our fare, we have removed our cabin number, so ticket we will not be using. So this is number, okay. Age is also fine, but if you can see the sex, it is nothing but male and female. So can you give your text data to your algorithm and find out, or does your machine learning algorithm take in alphabets? No, it doesn't take in alphabets, it takes in only numbers. So this is very important to understand, that you need to take in consideration not the numbers, but you need to take into consideration that is nothing but our data. So male and female cannot be used for training our machine learning algorithm. So instead of that, what we will try to do is we will try to replace them with some other data. So this is very important. Another thing that we will try to do is this embarked also. This embarked is again problems. What is the problem? Your embarked is telling you that it is the data that is, you have S, C and Q. So what is S, C and Q? I have already told you, it is the place of embarkment. That is nothing but the place where the people aboarded the ship. So again, our machine learning algorithms cannot take in our data, that is nothing but our alphabets. We need to give out our numbers. So to give out our numbers, as I already told you, we need to put some dummy values or replace this with numbers. So what we'll try to do is, if it is male, we'll use it as 1. If it is female, we'll put it as 0, or vice versa, anything we can do. So we need to replace these alphabets with numbers. So here also we need to replace this S, C and Q with numbers, so that we can try to predict something, or we can give our machine learning algorithm to train. So very important, you can't use alphabets anywhere in your machine learning program. That is why you need to use your numbers. So how to add this dummy values is nothing but pretty simple. So I will create one variable called as sex, which is a small lettered one. So in the column that is in our original column, it is a capital lettered one. So I am creating another value that is nothing but a data, empty data type, that is sex. So pd.getDummies is the function. So what is this getDummies function? I will tell you. So as you can see here, we had our first name and last name, that is Jason Miller, and we have a column called sex here. So sex is nothing but our male and female. So what our pd.getDummies do is, it is nothing but a pandas function. So when you use getDummies for a particular column, so when we use this particular column called sex and we'll try to get dummies, what it does is, it will see how many categories of data is there in this entire column. So in this entire column, we have only 2 categories of data, that is male and female. Male and female. So this is the thing that we have here. So what we'll do here is, it will try to add 2 new columns. So we had just 3 columns here, that is nothing but first name, last name and sex. So since we added some dummies, that is we used pandas.getDummies. So what it did was, according to the category which is there in this column. So this column has 2 categories, one is female and the other one is male. So using this female and male, it added 2 new columns of categories as separate columns. So we have female as one column, male as another column. Again, after creating the columns, how will it actually add the values? So if female is not there in this column, it will add 0.0. If male is there, it is adding 1.0. So similarly, if female is there in the second column, it is adding 1.0, and what it is doing is, if male is not there, it is adding 0.0. That is how this pd.getDummies is working. So what it is doing is, it will take in a particular column which you mentioned. So then it will see how many categories are there. So after seeing the categories, it will create new columns according to the categories. So what it is doing is, female also it is creating one column, male also it is creating another column. How it is adding values here? So if male is there in that particular, that is nothing but row, it will try to add 1.0 to male and 0.0 to female. So similarly, vice versa, it is doing. So this is the function that pd.getDummies does. It is adding two new columns. That is what it is. Yeah, now applying the function now pd.getDummies. So which data we need to apply? Data of which column? That is nothing but the sex column where we have our male and female data. Okay, so now we have this particular thing, but what we'll try to do is, it is pretty simple. So what is the concept that we are trying to achieve here is, so once we add dummies to our data, we'll remove the first column. So why do we need to remove the first column is pretty simple. So basically when you try to add columns, so we added two new columns, but what we are trying to do here also, it is pretty simple. So we have two columns that is added extra, but increased columns means that you have more and more computations to do. What we can do is we can either remove this male column or remove this female column. So what happens now is when you remove this male column or when you remove this female column, so since we already know that here if it is 0.0 and the other column it should be 1.0. So similarly, if in the female column it is 0.0, then in that is nothing but it is male is also 0.0. If the female column is 1.0, then it is indicating that the male is 0.0. Since these two are contrary values, we can remove any one of the columns. So that is what we will be doing. What we will be doing is we will be dropping the first column. So why we are doing this is basically to indicate that if there is one value, that is nothing but if there is 0.0 here, obviously if the female value is not there, it should be a male in the next row. So that is why we to remove our nothing but extra columns to increase our computation, we have removed this. So what we are trying to do is we will add two columns, that is female and male dummy columns. We will try to remove that. What we are doing is we will try to remove one extra column because 1.0 in one column indicates that it is 0.0 in the next column, that is in the respective row. So that is why we are removing those extra columns. So this is the operation that we are doing. So even though we are inserting our dummies to our column data of sex, we'll use this drop underscore first. So what is this drop underscore first telling us? Remove the first column. So this is what we are doing. So we are removing the first column. So similarly, embark also will do the same thing. So you can copy and paste the same thing. So what we are trying to do in embark also, we are trying to add our data. So what data we are trying to add? So I'll type in embark here. So if you can see the column here, embark. So you have SC and Q. So we have our columns, that is nothing but in embark we have SC and Q. So when we have SC and Q, so what we'll be doing next is we'll be creating two columns again named SC and Q. So what we'll be doing is if S is there in that particular column, we'll add 1, otherwise we'll add 0 and 0. So here also what we'll do is we'll remove this first column. So when we remove this first column, if it is 0 in the other two columns, obviously S is the data that we are considering. So this is how we are trying to achieve some dummies here. So using this dummies, what we are trying to do is we are trying to create 3 new columns according to the category embark, SC and Q. But we'll remove the first column because we don't need to use more and more columns, which will increase the time and which will increase the nothing but the amount of computation that is required to calculate for the algorithm. That is why we need to remove the extra columns. So we'll keep in only 2 columns that we'll try to analyze the data. So if it is 0 in the 2 columns, obviously the third column must be 1. So that also we will try to do. So we are removing this and here we'll name it as embark. So this is nothing but a small, this is nothing but the other variable I created. So this is nothing but the variable sex. So this is different from this because this is the actual column. So here we try to create another dummy column here. So if we try to print this data, so if we try to print this data, we'll see what exactly we'll get here. So we'll try to print embark and we'll try to print our sex data. So here we'll try to comment out because I don't want to see my graph again. Okay, so if we try to print it here, okay, the function is get underscore dummies. Sorry for that. So the function is get underscore dummies. So you can try to run it again. So as you can see here, very important. So we have only one column here. So since I use drop first is equal to true, we have only one column, that is male, which is indicating that I have 0, 1, 0, 0, 1. So what this is telling you is, if male is 1, obviously that the data is male. If male is 0, then obviously it is female. So similarly we have our data. So we have Q and S here. So C is removed. So when we have 0 and 1 here, so S is the data. When we have both zeros, obviously the C is 1. So that is how we are making sense out of the data, and we are removing some extra columns as well. So this is how you add some dummy values. So instead of alphabets, you are adding some dummy values and removing the extra columns also. So now we have successfully completely got in all our data, and we have removed the data also, and we have added some new data. But very important thing that we need to do here is we need to remove some data. This is just a variable. We have not added this to our data yet. So this is just stored in section embark. So we need to add it to our whole data set. So how do we do that is pretty simple. So first we will see which one to remove. So as you can see, now we have removed this cabin data. So this is done. So what we need to remove now is, we need to remove some other data also. What is the data that we will be removing is, we will be removing our ticket data here. So we don't need ticket, we don't need name data, that is name also we don't need. So this is also there. So name data we don't need. Other than that, we will take in all the data. So name data and ticket data will remove, but we'll remove this embarked also and sex also, because this has alphabets, and we'll try to append the new data that we have added. That is nothing but small letters. That is nothing but small lettered sex and embark. So these two data are nothing but are dummy added data, that is nothing but numbers. So we'll try to add those, and we'll try to remove the original data. So we'll use the data.drop operation. So we'll use the data.drop operation. So what are we removing now? We are removing the columns, that is original column sex, which has male and female, which is alphabetical data. Then we'll remove embark. So then we will remove the other data. What is that? Name and ticket. So we'll remove name, and also we'll remove ticket. Okay, this much of data we removed. And how do we need to remove it? We need to remove it column wise. That is why we'll use access is equal to 1. And after removing it, let it be stored inside our same data, that is data. That is why we'll use in place is equal to true. So this is what we did now. So all the data is removed, but we need to append the data also. What we need to append? We need to add out two data. We need to, which data we need to add? This small letter sex and embark. So this small letter sex and embark has the dummy equivalent. So what is dummy equivalent? Instead of male and female, we have 1, 0. Here instead of embark, that is SC and Q, we have new columns created which S and Q, so which have numbers. So that is why we need to add them. So how to add columns? It is using concat operation. So we use concat operation. So what are all the three that we need to concat? We'll concat this data, so which is having all the other data, which is nothing but our whole data set. To our data set, what we need to add? That is sex and embark. So these two columns we will add. Yes. So again, addition of columns, is it row wise or like column wise? It is column wise. That is why I'll use access is equal to 1. So after using access is equal to 1, okay, column I need to add this braces here. So access is equal to 1. So now closed. So if we can print out the data now, so we'll try to print data. We'll see what is the data that we have. So this data should not have any alphabets. It should have only numbers in our column. So very important to understand. So as you can see here, we have just our numbers everywhere. So we have our numbers everywhere. So we can consider this, and we can try to predict our logistic regression. So this is the difficulty that is involved. So in other data sets, you would just take in the data, apply logistic regression, and just get done with all the processes. But here it is difficult because a lot of operations are involved here. So similarly, we'll use our from sklearn, we have our test train split. So sklearn.models underscore selection. So we have our train test split. So import train underscore test underscore split. So this we are trying to like import. So what we have now is x underscore train comma x underscore test. So then similarly y underscore train. So you can use any caps or small letter, it all means the same. Y underscore test is equal to, what we need to do, we need to split our data, train underscore test underscore split. Which data I need to split now? I need to split my x data. So what is our x data? So very important to understand, here our data contains nothing but, our data contains what? All the data including our survived column. So this is the y that we need to calculate. So we need to include all the columns which we had included except the column that is survived. So why we need to drop survived is our y. So x is nothing but our data. So what is our x data? X data is all the data except survived. So what we'll do is we'll drop survived. So we'll drop this survived column. So we could do it separately also. We can keep it as a separate variable, but I am trying to squeeze in here itself. So x is nothing but our data drop of survived. So it is telling that it includes all the data and it includes our survived also. So what we are trying to do is we are including all the data except our survived in the x, but y should have only survived. After doing that, what should we do now? So we have our x, that is nothing but all the data except survived. What should be our y? Y should be our survived. Because we are comparing our x and y. So what is x? All the data without our, that is label. So label is 0 and 1. We are predicting whether the person survived or not. That is our x. So y is nothing but our survived data. So after that, what we need to tell, what is the test size? So test underscore size is telling us what is the test size. So you can keep it as 0.30, 0.20 and your wish. And random state, so what I have told you what random state already does. So it is telling you that what is the data which goes into splitting, that is nothing but what is the data which goes into training and testing. So we need to maintain that same data for our entire operation. So that is what we are telling now. So since we did this, so we split our data into training and testing. So our x is nothing but everything except our data of survived. So we have dropped the data of survived along the column wise, axis is equal to 1. So then our y is data of survived. So that is clear. So test size is telling you how much of data must go into testing, 30%, and random state is telling you the variables which will go for testing and training, let them be the same. So you should not keep the variables which have gone for training and testing differing every time. So they will maintain a common random procedure or random numbers which will remain the same for our entire iteration. So that is what we are doing. So I have explained it clearly in the previous things. You can just go and check out how exactly that is nothing but our random state is working. So now we split our data. So we'll use our sklearn.linear model. sklearn.linear underscore model. So what we'll be trying to do is we'll be trying to use our logistic regression. So how to use our logistic regression? Import logistic regression. So we have our logistic regression here. So what we'll try to do is we'll create a variable that is nothing but log model is equal to logistic regression. So we are creating another variable, so which is called as log model. So that is nothing but the name of the model. So we are, instead of using logistic regression every time, that is the function, I can use this other word or variable instead of logistic regression. That's all we are doing here. So after creating our using our logistic regression model, so we need to fit it to our data. So what we need to do, we need to give our data, that is x and y. So which data we need to give, training or testing? We need to fit our data with training data. Why? This is the training part where our algorithm is getting trained. So we have our x train and we have our y underscore train, where we'll try to fit in the data. So what we are trying to do is we have created a logistic regression function. So x is nothing but all the data except survived. So y data is our survival data. So we are trying to train our algorithm according to our x and y. So we are training our model for x train and y train. That is telling you that our algorithm is getting trained, or fitting is nothing but training. So we are giving our training data. Now we'll try to predict. So what I'll do is I'll name this as predictions, a variable. So predictions is equal to what? Log model dot predict. So logistic regression model. So we just named it predict. So when we are trying to predict our data, that is nothing but we have our predictions. So what we are trying to predict here, when we give our x underscore test, it should predict the values. So that is nothing but it should be similar to our y underscore test. So predictions is the one which our model is predicting, which our trained model is predicting. So y underscore test is our actual values. X underscore test is the one which is actually predicting. So you can print out the predictions. So everything remains the same. So whatever we did in the last example, it remains the same. But all the data cleaning operations were very important here. So what we did was we tried to use our whole concept of nothing but logistic regression to just try to understand how our predictions are happening. So what we did, we created a logistic regression model. We trained our data with X train and Y train, that is fitting. So then we gave our testing data, that is nothing but X underscore test, to predict our Y underscore test. So this is the predicted value which the algorithm predicted. So we can just see how accurate it is predicting by just using our nothing but data, which is our confusion matrix. So I already told you confusion matrix will predict two things, that is nothing but what are the correct predictions versus what are the wrong predictions. So this is what it will predict. So confusion matrix is telling us according to the two classes 0 and 1 how many correct predictions and how many wrong predictions our algorithm did. So it is comparing our two values, y underscore test and our predictions. So y underscore test and predictions are nothing but y underscore test is the actual value in our data set. Predictions is nothing but the value which our algorithm predicted. So what is our confusion matrix? Confusion matrix is nothing but matrix dot confusion underscore matrix. So this is the function. So what we need to compare are y underscore test and which prediction. So these two will compare and we'll try to see what is the result. So print, and we need to give out confusion matrix. So if you want to give out our own values, what should you do? You should give out your double array. So that is nothing but if you want to create your own value prediction, you should use your double square brackets to give out your input values, so you can predict the output values whether the person survived or not. So now we will try to print out the confusion matrix and see how well it has got trained, and we will even see the values, that is nothing but our y predict. So what is our y predict or the prediction which it did? So this is the prediction it did. Ignore the warning. So that is for the version. So this is the version warning you would get. So here you are getting 144.22. So what is 144.22 out of class 1? So out of this class 1 is telling you that the person didn't survive. So out of 166 people who didn't survive, 144 our algorithm predicted properly, 22 it didn't predict properly. So out of the 0 of the people who didn't survive, or who class 0, we have 79 properly predicted, 22 improperly predicted. So this is what our confusion matrix is telling. So this is our predicted, that is nothing but our y predictions that is predicted by our algorithm. So if you want to give out your own value, you should use your own data to tell out what is the data columns you have and what is the prediction that you want to do. So if you want to check for your own values, it is pretty simple. We'll use this log model.predict. But after doing that, we need to enter our own values. So we need to use this double list option. So that was nothing but our NumPy array format where you need to enter our values. So 1 is telling us our passenger ID. So 3 is telling you our passenger class. So if the person was around, that is nothing but passenger class was 3 and the age was 22. So then we had one sibling, so no parents on board. So he paid a fare of $7.25 and then he was a male person. So if he embarked the ship in which place, that is nothing but if he embarked the ship in Southampton, or if he embarked the ship in S, so it is nothing but Q and S. So we have C removed, so it is 0 and 1. So if he has embarked in Southampton, it is 0 and 1. So if you want to see whether the person survived or not survived, so if it is 1, then the person survived. If it is 0, the person didn't survive. So he was a male person, 22-year-old. So he didn't survive. So this is 0 is telling you that he didn't survive. So this is how you do it for your own value. So this was the entire concept of logistic regression with data cleaning. So thank you guys, and I hope you had a wonderful session. And I will be posting the data set as well as our program also. Thank you.